Once you have a testable hypothesis, you will know what data is to be collected, and you need to identify the statistical analysis to answer that question. In the prerequisite statistics course, you learn to estimate and test means or proportions using the standardized normal probability distribution, also called the z-distribution, and the student's t-distribution. If you took Math 211 or 222 at Embry-Riddle, you use StatCrunch for the computations. There are numerous other software packages that are used in classrooms or by statisticians. None of these will do you any good if you select the wrong analysis for the question you are asking or the data you have to answer it. The first decision along your path to analysis is whether you have categorical or numerical data. With categorical data, the research question and hypotheses will be about a population proportion. Sometimes the wording will be about a percentage, which is a proportion times 100%. When the research question and hypotheses are about a mean, variance, regression coefficients, or correlation, you will be working with numerical data. Here are two types of proportion questions that may have been asked and answered in the typical first class in statistics. There may not have been any testing of numerical data other than the mean in that introductory class, but here are a couple of examples for means. All four of these examples are two-tailed tests. The not equal to sign in the alternative hypothesis indicates that our question is only concerned with evidence that the sample statistic is significantly different than the hypothesized population value, without any concern for it being either greater than or less than that value. Deciding on a two-tailed test or a one-tailed test is another step in selecting the appropriate analysis, but we haven't finished listing the available tests, so we'll come back to that choice in a couple of slides. Here is another t-test you saw in the prerequisite course. Notice that this is a test of mean differences, whereas the previous slide showed a test of the difference of means. We'll clarify that some more in an upcoming video. Unless you took the prerequisite course somewhere other than ERAU, you never tested the statistical significance of the regression equation or correlation coefficient that you learned to calculate, but scholarly research would require that you do. The coefficients of the regression line for a population are beta 1 and beta 0, but it is the slope that matters. A slope of 0 would mean that there isn't a relationship between the two variables, so we test to see if the slope from the equation generated by the sample is significantly different from 0. The test for slope uses the F distribution rather than Z or T, which is why it is often left for a second course in statistics. Using a t-test on the population correlation coefficient only makes sense if the slope is statistically significant. That's the Greek letter rho, by the way, not a p. Also left for a second course are some additional ways to analyze categorical data using the chi-square distribution. The results of this test are nearly always the same as the z-test, but has the advantage of stretching to multiple proportions. Finally, there is also a test for the relationship between two categorical variables. All hypothesis testing is a matter of comparing a sample statistic to a hypothesized value. The tail of a test indicates which side of that hypothesized value you are paying attention to. The a-directional case is when it isn't important whether the sample statistic is less than or greater than the hypothesized value. You are only interested in a statistically significant difference from the stated value, hence the not equal to sign. Directional testing is necessary when your question involves a direction of interest to the researcher. If you imagine those inequality signs as arrows, you can remember which direction you are interested in. We now have a list of 10 statistical tests commonly used across a wide range of research applications. Psychologists, engineers, marketers, educators, economists, linguists, and sociologists are just some types of researchers who are familiar with these statistical tests. I'm going to add one more important test to this list, although it wasn't mentioned earlier. Analysis of variance. This is only one use for analysis of variance, but creating an interesting research question as an undergraduate just might lead you to this one.